So misclassification bias is another type of bias that affects studies, and misclassification bias is when the study participants are misclassified with regard to either the disease or the exposure. So the information that's recorded in the study about disease or exposure is incorrect, and sometimes this is also called a type of information bias because the information is biased. So there are two different kinds of misclassification bias. There's differential or non-random classification bias, and then there's non-differential or random misclassification bias. Okay, so we have schematics over here, and so these just show the designs of the case control and then the cohort, cross-sectional, or RCT, where in each of these designs you've got two groups that you're comparing. And case control, it's the cases and the controls, and then the other designs, it's the exposed group versus the unexposed group. And so for differential or non-random misclassification bias, the misclassification of the exposure or disease occurs differentially in either in one group or another. Okay, so if we're talking about a case control study, you might get more misclassification in the cases than in the controls. And if you're talking about the other designs, you might get more misclassification in the exposed versus the unexposed. So it's non-random across the groups in the study. And then so the other type of misclassification bias is random. So in this case, the misclassification occurs randomly across cases and controls, or exposed and unexposed. Okay, so an example of a differential misclassification bias is a recall bias, which we've talked about before. The recall bias occurs in a case control study. So for example, we say we have a case control study and we're looking for the causes of birth defects. And so we have cases, a set of women whose babies were born with birth defects, and then we have a set of control women whose babies were not born with birth defects. And we ask each of the participants to recall a variety of exposures. So for example, x-rays that they had had before and things like that that might be related to the disease. And so in this case, what often may happen is that the cases, because they know already the disease has already occurred in a case control study, so these mothers who are the cases have spent a lot of time thinking about what might have caused this birth defect. So they've thought a lot about the exposures that potentially may be related to birth defects, whereas this mothers in the control group may not, because they're not trying to explain any problems because they didn't have any problems. So in this case, we have a differential memory for the exposure in the cases relative to the controls. So the controls, we may be more likely in this case to misclassify the exposure in the controls than we are to misclassify the exposure in the cases, because there's a recall bias in the cases where they're more likely to remember exposures. So that's an example of a differential misclassification bias because it occurs more in one group than the other. So another type of differential misclassification bias is the surveillance bias. And in this case, the disease is misclassified more frequently in one group than another. So the way that this works is here we've got a cohort study. And so the groups of the study are based on their exposure. And so here we're looking at the relationship between smoking status and emphysema. And so our exposed group are smokers, and non-exposed, obviously, are non-smokers. And so what happens is that because physicians know that smoking may result in emphysema, for smokers they may be more likely to test for emphysema than in non-smokers, and therefore you might be more likely to misclassify non-smokers as not having emphysema simply because it wasn't detected. This is also called the detection bias. So the idea that if you know to look for something, if you're expecting a particular outcome from a particular exposure, you may be more likely, or it may be more likely that people with that exposure are diagnosed with the disease. So again, this is differential misclassification because the misclassification is more likely to occur in one group than another. In this case, the exposed group is more likely to be classified as having a disease than is the non-exposed group. And so this obviously exists for other exposures and diseases, ones in which the one exposure group is more likely to have the disease detected than another. So in non-differential misclassification bias, the exposure and disease are equally likely to be misclassified in each of the groups. Okay, so in the cohort or RCT design, the exposure and disease are as likely to be misclassified in this group as they are in this group. And similarly in the case control design, the disease and exposure are equally likely to be misclassified in this group and in this group. So you might think, well, that doesn't really matter, but actually the impact of non-differential misclassification is to dilute any effect. So if there's non-differential misclassification, the effect that your study estimates is going to be closer to the null than the true effect. So it'll be harder to find an effect if there's non-differential misclassification bias. Or, sorry, if there's non-differential misclassification. Okay, so here's an example I'm going to use to show you how this works. So this is a study that's looking at the effect of high-fat diet, which is the exposure, on development of heart attack. So this is a cohort study, and they were looking to see how many people in each of the exposure groups got a heart attack, and calculate the relative risk of heart attack for high-fat diet versus low-fat diet. So in this case, we can calculate the relative risk, which is the incidence in the exposed, which is 250 over the total exposed, over the incidence in unexposed, which ends up being 2.16. And so now, let's imagine that there's misclassification bias that is non-differential. So the exposure is misclassified, and it's misclassified equally in each of the disease groups. So let's imagine that our measure of diet is not very good, and so a lot of the people that actually do not have a high-fat diet in reality get classified as having a high-fat diet on our measure. Okay, so we're going to convert 20% of the no's that we have here into yeses. Okay, so we know that this is the correct classification. So now we're going to look at what happens to the relative risk when we introduce misclassification that's random. That is, it occurs equally across groups here. So here are the numbers after we've introduced this misclassification of 20% of no's turning into yeses. And so now let's see what happens to the relative risk. And here we can see the relative risk reduces or gets closer to null, null being 1, after we've introduced this misclassification bias. So even though this misclassification occurs equally across, in this case across disease groups, there's still an impact, and the bias still results in an incorrect estimate of the relationship between exposure and disease. And in particular, it results in a dilution of the effect, and so the effect comes out closer to 1 than it actually is. And so those are the different ways that misclassification bias can influence your study outcome. And again, these are things that are not correctable through statistical measures usually, but are a function of the design of the study. And so this is why you really want to have good measures for both exposure and disease so that you can get an accurate measure of the effect.